Our lesson for today will be looking at chemistry 1502. The topic for today is carboxylic acids. Lesson 101. Let us start. Carboxylic acids are one of the functional groups that we should know in order to understand the oxidation of alcohols, because this is one of the outcome functional groups when we derive alcohols. So you should know that carboxylic acids are organic compounds where the molecules contain a carboxyl group. It is not the same as the aldehyde and the ketones where they contain a carbonyl group. This one we say is a carboxyl group. And then the carboxyl group, you should know that we identify COOH, or we can say you have to identify this. Or identify something like this. And some say, which is true, a carboxyl group it's a combination of carbonyl and hydroxy. Carboxyl, it's COOH, and then a carbonyl, we know that it is CO. Carbonyl, it's when we have carbon bonded to oxygen, and then hydroxy group, we know that it is OH. So you can see that the combination of this will give you this. Combining a hydroxy group and a carbonyl group will give you a carboxyl group. You should know that the ending name, it's anionic, and then we add with acid. Without wasting time, let us look at examples. So the first one, suppose we have CH3 C double bond OH. Okay, how many carbons do we have? We have 1, 2, and then the carboxyl group will take priority in this case. So we have ethan as usual, and then we have to put the ending name for acids, which will be ethanoic acid. According to many textbooks, they would say, like I said here, it's based on the reference, the textbooks. The name is anionic acid, especially this anionic. I want us to talk about this. Now, for you to easily master this, instead of anionic, let us say oic acid. Because check, if you're talking about, let's say, hexane, we know that this belongs to alkanes. As you can see, the ending name is ANE. And then we want the carboxylic acid, whereby it contains 6 carbons, meaning that an acid version of hexane, instead of going for anionic to get confused acid, let us go for oic acid, meaning that if we change this, we are simply going to remove this. So we have hexane, and then we put our oic acid. Suppose we want to name this based on ketones, we are going to write hexane. Then remember, for ketones it's ONE, O. Then we put O. For the aldehydes, you can see it clearly works for all the functional group. We have hexane, and then we know that for aldehyde we're just going to put Al, hexanal. So let us use the oic acid instead of anoic acid. To show that this works, let us use other parent chains. Let us look at hept. So we know that from alkanes we have heptane, we have heptene from alkenes, we have heptyne, alkynes, and then starting with the hydroxy group, which is the alcohols, just going to put heptane, and then for alcohols we put OL, which is all, heptanol. For aldehydes we use heptane, and then we put Al. For ketones, use the very same weight, heptane, and then we put O and E, heptanone. And then for carboxylic acids, heptane, then we put oic acid. You can see the name, it's heptanoic acid. Also, when we go through the esters, you'll see that this will also work. So back to this, the name for this is ethanoic acid. By the way, we do have a methanoic acid, which is like this. This is methanoic. You can see it's a methanoic acid. We also have propanoic acid, and you can see that there's no need for us to label the position of this part because it will always be the first. So this is propanoic acid. Okay, let us look at this one whereby we have substituents. This will be 1, 2, 3, 4, 5, and 6. Carbon number 4, we have a methyl. Carbon number 5, also have a methyl. And then we have 6 carbons, so this will be hexanoic acid. So when we write this, we're going to say 4, 5 hyphen dimethyl hexanoic acid. Then we also have aromatic cyclic or carboxylic acids. Which is something like this. You can clearly see that this is a carboxylic acid and then this is a benzene ring. So the name for this will be benzoic acid. We do have a lesson video whereby we look at more examples of IUPAC naming, whereby we have compounds having different types of functional groups, how to name them. It is a practice question or a practice lesson video. We have about 2 to 3, whereby in each lesson video we look at 20 to 25 examples with this IUPAC naming, just to make sure that you master it. You make sure that before you watch the oxidation of alcohols, you watch the ketones, the aldehydes, and also the carboxylic acid, so that you can understand the outcomes of that particular reaction. That's it for this lesson video. This is Bahula SJ. Thank you very much.